In this video, we're going to use the method of completing the square to derive the quadratic formula. So a quadratic equation has the form ax squared plus bx plus c is equal to 0. And there's three main methods to solve a quadratic equation. You can use factoring. If the equation doesn't factor, you can use the method of completing the square. And if you want to go another route, you can also use the quadratic formula, which is the one we're going to derive. But the first thing you want to try is factoring, because that's the easiest approach to solving a quadratic equation if it factors. So let's review the first two methods first. Here's one where I have the equation 2x squared plus 7x minus 4 is equal to 0. This one factors. So factor into 2x minus 1 and x plus 4. And remember, once you have it factored, the only way a product can be equal to 0 is if one factor or the other is 0, or if they're both 0. So all we do is we set each factor equal to 0. 2x minus 1 can be 0, or x plus 4 can be 0. And then you solve each equation for x. Isolate the x term. So this is going to be 2x. Add 1 to both sides is 1. Add negative 4 to both sides. We get x can equal to negative 4. And if we divide both sides here by 2, we get x can be 1/2. So generally a quadratic equation, second degree, you expect to have two solutions, two distinct solutions, or you can have one repeated solution, or you can have no real solution. Or in some cases you can have imaginary solutions. So here if you factor it, it's pretty straightforward. You get x equal to 1/2, x equal to negative 4. Now to use the method of completing the square on this, it's easier to use the method of completing the square if the coefficient of the square term is 1. So usually they'll tell you divide through by 2. So divide everything by whatever the coefficient of the x squared is, if it's not already 1. If it's already 1, you leave it and proceed with the step that I'm going to do next. But here I divide through by 2. The 2's cancel. 7 divided by 2, leave it as 7/2, and then negative 4 divided by 2 gives me negative 2. And then we usually put this over. So we add 2 to both sides, and it gives me x squared plus 7/2 x is equal to 2. So to put this in a form that I can solve, the procedure is, and that's why we need this to be 1. For this to work, that has to be 1. You take the coefficient of the linear term, that's the x, multiplied by 1/2. Okay, 1 times 7 is 7. 2 times 2 is 4, so we get 7 over 4. And then you square it. You square this, gives me 49 over 16. And then we add what we got, 49 over 16 to both sides. So that's what I have in this step here, 49 over 16, and we add 49 over 16 to the right side. Got to keep it balanced, so whatever you add to one side, you add to the other side. Okay, then from this point, from this step right here then, what we did is, this is 2 over 1, so we multiply by 16 to get the same, or the common denominator. Multiply here by 16, so I get 2 times 16 is 32 over 16, and 49 over 16 gives me 81 over 16. We get that. And then on the left side, the x squared plus 7/2 x plus 49 over 16, that's actually a perfect square. And that's what this is about, of course. We're completing the square by taking half the coefficient of this x term, squaring it, and adding it to both sides. And that completes the square, because notice this trinomial factors into x plus 7/4 squared. Notice, check it out. X, so you square binomial, you square the first term. So x squared is x squared right there. 7 over 4 squared is 49 over 16. And then to get the middle term, it's double this product. So 7 over 4 times 2. 2 goes into 4, 2. I get 7/2. So it checks. Now from this point here, it's just like if you had x squared. You were solving an equation, it came out to x squared is equal to 4. You say, okay, take the square root of both sides. Plus or minus though. So square root of x squared is x, and square root of 4 is 2, and it's plus or minus. You get your two roots, a negative and a positive. End up with that. Over here, the same thing. Take the square root of both sides. The left side is a square, so when you take the square root, it just gives you x plus 7 over 4. That's going to equal to plus or minus the square root of 81 over 16. Square root of 81 is 9. Square root of 16 is 4. So I get then, adding a negative 7/4 to both sides, so isolate the x. I get x is equal to negative 7 over 4 plus or minus 9 over 4. And then we just combine these. Use the positive and the negative. So let's first say minus 7 over 4 and a plus 9 over 4 gives me 2 over 4, which reduces to 1/2. And then use the negative. Minus 7 over 4 and minus 9 over 4 gives me a minus 16 over 4. Gives me a negative 4. There's your answer. You can see it's a lot easier doing it this way. But sometimes it's not got a factor. Sometimes it's not got a factor. So let's say you were working this and this came out to something that wasn't a perfect square. Let's say this came out to just a plain old 2 here. Then when you take the square root of the right side, plus or minus, you'd wind up with plus or minus the square root of 2. So your answer would be an irrational solution. Everything else, of course, would be the same, except you leave this in form of the radical, and that would be the solution. But in this case, you can see we get the same thing, but this one here, it's a lot easier. So now, using the same technique, we want to generate the quadratic formula. And some students would say, well, why do we need to generate it? I just want to know how to use it. And that's true. If you know how to use it, that's fine. But if you get into more advanced mathematics, even in trigonometry, you have to derive formulas, prove formulas. So if you're just taking one math course and you know how to use the quadratic formula, more power to you. But there's some students that like to know, why does it work? Why does this formula work? How do I know it works? Well, some of these you can prove. So let's take the first one. Okay, let's in this form here. Condition, of course, a cannot be 0, because if a were 0, then you don't have this term. And that's just a linear equation. You just take the c over, divide by b, and you got the answer. But in this case, what we're going to do is this. Same thing, except we're dealing with a, b, and c instead of actual numbers. So I'm going to get b squared, b over a, x. Then the c, I want to take it over to the other side. So that's going to be negative c. And of course, I'm dividing through by a. Okay, so I took the c over to the other side, or added negative c to both sides, then I divided through by a. It's the same thing we just did with the one I solved using the this particular method, except I don't have actual numbers here. It's b over a minus c over a. So this is a point now that I have this to be a 1. That's the thing about it. This procedure is going to work if the coefficient of the square term is a 1. So if it's not a 1, divide through by that number. If it's already a 1, you just simply skip that step and you start with the next step, which is this one right here. We take 1/2 the coefficient of the x term, b over a, so 1/2 times that gives me b, 1b over 2a. And then we square it. So this gives me a b squared over 4, a squared. And that's what I add to both sides here. So in my next step, I would rewrite this whole thing again, and then send put a plus b squared over 4a squared. And then I add it here also, both sides. Let me write this a little better here. Get that. Now by doing that, I'm able to factor this. I've completed the square on this trinomial on the left side, so it should factor into the square root of x squared is x. Whatever the sign of the middle term is, that's plus. And the square root of b squared over 4a squared. So this will be b over 2a squared. And you can see it checks. If I square this binomial, it's the square of the first term, of course, gives me the x squared. Double this product, so that would be x times the b, and then times a 2, cancels this 2, gives me the a. So that checks out. And then the b over 2a squared is b squared over 4a squared. And then on this side over here, let's put this over the same denominator. So this is a 4a squared, and this is an a, so I need to multiply this one by 4a, and this one by 4a. This is a times a, 4 times a times a is 4a squared. Then I have the same denominator, so I'll just regroup. I'm going to put the b squared first here, squared, and then I have 4a, or minus 4ac, so this minus 4 AC. And this is the point where I take the square root of both sides. So the square root of the left side has squared, it just gives me x plus b over 2a. And then the right side I take plus or minus. But first, so on the right side I take plus or minus the square root, so it'll give me plus or minus, and I just take the square root of the numerator, it's the same thing, so plus or minus the square root of b squared minus 4ac. And then the square root of the denominator is just 2a. And then I'm ready to solve for x. So x is equal to plus b over 2a. I want to solve for x, so I take this over to the other side, so it becomes a minus b over 2a. The denominator over here is 2a, so I could just put it over one denominator. This will be a minus b plus or minus the square root of b squared minus, and then this should be here. It's just 4ac here, so they'll need a c here, c. And this is over here, 4ac. That's over 2a. And that's how you generate the quadratic formula that can be used to solve any quadratic in this form. So the only thing you have to remember is that you have to write it in this form: ax squared plus bx plus c equals 0. One side has to be 0. And then you just take the coefficient of the square term, that would be the a, the coefficient of the x, that would be the b, and then the other number, if there is one. If there's no other number here, that's 0. And you just plug those values in the appropriate places in this formula, simplify your radical, and you get your solution. Thanks for watching. We'll see you next time.